Hello, my name's Graham Sandville and I work with New South Wales Department of Primary Industries, and today I'm going to be talking to you about a plant that was bred in the future farm industry CRC called Lotus corniculatus.
Its common name is bird's foot trefoil. It's a perennial legume. It's adapted to acid and waterlogged soils. It's suitable for sowing with subclover in the 650 to 850 millimetre rainfall zone, where at least 100 millimetres of rainfall occurs over the summer period. It's non-bloating and it fixes atmospheric nitrogen. We're now going to step back in time and look at some of the steps that occurred before the Lotus corniculatus breeding lines were produced. The first area we're going to look at is problem identification. As part of the problem identification for Lotus corniculatus, we're going to look at the target zone for Lotus corniculatus and how it was conceived. In the first instance, this shot is of a landscape where to the left you have hotter, drier, longer summers with higher pH, and to the right you have cooler, moister, shorter summers with lower pH. In the rainfall zone below 650 millimetres we have largely outcropping and grazing landscape, and there are a range of annual legumes and lucerne sown in that area. In the high rainfall zone above 850 millimetres, the legumes mostly sown are white clover and subclover. And in the target zone that we're talking about for Lotus corniculatus, the 650 to 850 millimetres, subclover is primarily the legume sown. There are largely no perennial legumes sown in this zone, and the reason for this is that the soils are too acid or waterlogged for lucerne, and the summers are too harsh and dry for white clover. To look at the acid soils, this map here shows where those acid soils are for New South Wales and Victoria, and they are confined to those higher rainfall areas. The other important part of problem identification was looking at the legume content required to drive maximum livestock and pasture performance, and there are a number of authors that have found that the ideal legume content ranges between 20 and 60% of the pasture. There's been a number of pasture surveys, however, that have found the legume content of pastures is well below this ideal range. Only one, in fact, by Kemp and Dowling, found legume content to be adequate. So the most commonly reported range of preferred legume content is 25 to 45%, while the most commonly reported range of legume content in pastures is 5 to 20%. So there was a big difference between what's needed and what exists. Once the problem identification phase was completed, a breeding program was commenced, and the first step was to collect wild accessions overseas and bring those into Australia through quarantine and assess those plants for their attributes. 303 wild populations were deemed adequate to include in the breeding program, along with 63 elite breeding lines that we were able to acquire from Inya, Uruguay under agreement. And both sources of these populations were sown on farm in acid soils. And the very best individuals from the best populations were then selected, crossed, and their progeny sown back out on farm. This process was repeated, and the best individuals out of that population were selected to produce a cultivar. This was funded by Australian Wool Innovation. Once the plant breeding phase was completed, seed increase was undertaken for 4 lines of Lotus corniculatus that were bred in the breeding program, and plant breeders' rights was undertaken for those 4 cultivars and granted. The next phase of this work is looking at on-farm testing.
Lotus corniculatus is waterlogging tolerant, so it will withstand periods of water inundation where lucerne won't. So in the high rainfall zone, Lotus corniculatus is often very useful where you get winter waterlogging.
These results compare the dry weight expressed as a percentage of the free drain control for Lotus corniculatus and lucerne under waterlogging, and for Lotus corniculatus and lucerne under a recovery phase where there was no waterlogging. Firstly, you can see that Lotus corniculatus under waterlogging conditions produces more dry matter than it does under free drain conditions, whereas lucerne, it produces dramatically less dry matter production. When you look at the recovery phase after waterlogging, again, Lotus corniculatus is producing a lot more dry matter than its free drain control, whereas lucerne is not. It's producing substantially less than its free drain control.
Lotus corniculatus is tolerant of acid soils and much more tolerant of those acid conditions than lucerne.
This graph compares the dry weight expressed as a percentage of its own control for Lotus corniculatus and lucerne at two different levels of aluminium, at two different levels of manganese, and at a combination of Al and Mn. Here you can see that aluminium in both of these concentrations, Lotus corniculatus is performed better as a percentage of its control compared to lucerne. The same has occurred when Mn is the stress, and when the stresses are combined, we find that again Lotus corniculatus performs at a higher level as a percentage of its control compared to lucerne. Results from the Holbrook site show that Lotus corniculatus produced more dry matter than subclover in November 2012 and April 2013, whereas subclover produced more than Lotus corniculatus in September 2013, October 2013 and March 2014. At Bynalong, the results show that Lotus and subclover performed the same in September and October 2013 and March 2014, and at Yass, the results show that in spring 2012 subclover outperformed Lotus, while in March 2013 Lotus outperformed subclover. That was after a false break that subclover seedlings died in. The results therefore show that at Holbrook the summer was too harsh and subclover performed better than the Lotus corniculatus line. At Bynalong, both the subclover and Lotus corniculatus line performed the same, and at Yass, the Lotus corniculatus line performed better than subclover after an autumn false break. The conclusions for the Lotus corniculatus lines developed in the Future Farm Industry CRC are that they're best suited to cooler summers where the average annual rainfall is above 650 millimetres and at least 100 millimetres of rainfall occurs over summer. The lines can provide protection against false breaks where subclover seedlings die in autumn, and the lines are also ideally suited to winter waterlogged conditions.